Parallel vectors. To understand the term parallel vectors, first we will get the concept of parallel lines. Two lines, say A and B, extend these lines from both ends up to infinity. I am showing extension by dots. If these lines do not intersect each other, then these are parallel lines. Students, these lines will intersect if perpendicular distance between them increases or decreases. Students, now consider two equal vectors A and B. Now think, will they intersect each other at any point if we extend them? The answer is no, because they are in similar direction and distance between them is constant. Students, now consider another vector C, which is 5 times A. Consider another vector D, which is minus 10 times A. As perpendicular distance between vector A and vector C remains constant, similarly the perpendicular distance between vector A and vector D remains constant, so we can say these are parallel vectors. Now we can make a conclusion, that is, two vectors A and B are said to be parallel if they are scalar multiple of each other. Mathematically, we can write A is equal to m times B, where this m may be greater than 0 or less than 0. As null vector has arbitrary direction, so we can say null vector is parallel to every vector. Our next topic is rectangular coordinate system in space. Students, three mutually perpendicular lines OX, OY and OZ with same scale of measurement are said to constitute rectangular coordinate system. The lines OX, OY and OZ are called the rectangular coordinate axes and referred as x-axis, y-axis and z-axis. This point O, which is point of intersection of these three lines OX, OY and OZ, is called origin, and these three axes determines three planes: xy plane, xz plane and yz plane. These planes are called the coordinate planes. So xy, xz and yz are coordinate planes. Students, consider the rectangular coordinate system in 3 dimensions as shown in the figure. Now take points A with coordinates 1, 0, 0 on x-axis. Similarly, take a point B with coordinates 0, 1, 0 on y-axis and a point C with coordinates 0, 0, 1 on z-axis. Now we can make here three vectors OA, OB and OC. Students, you can see these three vectors in red color. Now we can denote these vectors with some notations. For example, vector OA with I unit vector, OB with J unit vector, and OC with K unit vector. Students, we call these I hat, J hat and K hat as unit vector because their magnitude is 1. Now I will talk about the direction of these unit vectors. I unit vector is in the direction of x-axis while J unit vector is in the direction of y-axis and K unit vector is in the direction of z-axis. Components of a vector. Consider A be a three-dimensional vector, P is its initial point and Q is its terminal point. Coordinates of P are x1, y1 and z1, while coordinate of point Q are x2, y2 and z2. One can draw images of PQ on x-axis, y-axis and z-axis. I am drawing here in red color. Then the numbers A1 equal to x2 minus x1, A2 y2 minus y1 and A3 equal to z2 minus z1 are called rectangular components. In fact, these are images of vector A on three axes, x-axis, y-axis and z-axis. We can make three vectors from these rectangular components. This A1 I unit vector is in the direction of x-axis while A2 J unit vector and A3 K unit vector are in the direction of y-axis and z-axis respectively. We call these three vectors component vectors. So these are component vectors of vector A. Our new topic is analytic representation of a vector. Let A be a vector with initial point at origin. Consider the coordinates of point P are A1, A2 and A3. This P is terminal point of vector A while O is its initial point. To draw the components of vector A, first of all I will draw a perpendicular from point P to xz plane at point Q. This PQ in fact z component of vector A, so we will denote it A3 K unit vector. Now to draw x component and y component, I will draw a perpendicular from point Q to x-axis at point R. Here QR is y component of vector A, so we will denote it with A2 J unit vector. In the figure, OR is x component of vector A and it is denoted by A1 I unit vector. Now from polygon law of addition, it is clear from the figure A1I, A2J and A3K are three vectors and A is their resultant vector, so we will write it as A is equal to A1 I unit vector plus A2 J unit vector plus A3 k unit vector. Now we will discuss how we can find the magnitude of vector A. To find the magnitude of vector A, we will apply Pythagoras theorem. In right triangle OPQ, which is shown in green color, by applying Pythagoras theorem, we have OP square is equal to OQ square plus QP square. In the figure you can see there is another right triangle which I have shown in light blue color. By applying Pythagoras theorem on this ORQ right triangle, we have OQ square is equal to OR square plus RQ square. Now put this value of OQ square in equation number 1 and we have OP square is equal to OR square plus RQ square plus QP square. As OP is equal to A, so OP square is equal to A square, OR is equal to A1. So we will place OR with A1 and RQ with A2 and QP with A3, and we will get this equation number 3. By taking square root both sides, we have A is equal to square root of A1 square plus A2 square plus A3 square. This A is also known as magnitude of A. So we will use this formula to find the magnitude of any vector. As we know that I unit vector is equal to 1 I unit vector plus 0 j unit vector plus 0 k unit vector. To find its magnitude of I unit vector is equal to 1 square plus square of 0 plus square of 0, because this one is A1, this 0 is A2 and this 0 is A3. We will write here a square root. Finally we will have 1 and its square, which will be equal to 1. So magnitude of unit vector is 1. Thank you for listening this video.